All right, here we go. Wow. Day one. There we go. All right. So before we get into electricity, we're going to circle back around. We'll talk about math this week. And the way I want to do that this week is pretty much cover a lot of the problems that you would face on the FAA test and take a look at how we can do them. Now, obviously with math, there are different methods sometimes to get to the same thing. So I'll kind of show you what I'm thinking. If you've got something else that you're thinking, maybe we can look at that one, but I don't want to confuse too many people. So one of the first things that we talked about when we talked in 309, and of course we're going to be using our calculator and using that, we started with fractions. And I don't know, a lot of you probably hated fractions. How do you feel about fractions now that you have your calculator, know how to use it? A little bit, okay, so much better about that. So I went through the FAA test questions and said, took a look at what are some of the questions and what do they look like. So some of these are the FAA test questions, actual questions that you'll see on your Q&A tests, and some of them are not. But anyway, so one of the first questions that I run across here is, what is the total thickness? So total thickness. Total thickness of some sheet metal that is 1/16. We have a 3/32 piece of sheet metal and a 1/4 inch piece of sheet metal riveted together is what the question asked. Now, by the way, this is a very relevant question, and the reason why you have to know that is because when you get into sheet metal with fill, you're going to learn, I'll teach you right now, that is considered the grip. The grip is what is the sheet metal together. So in order, you have to figure out what size rivet you're going to need for the sheet metal, and there's a formula that you'll get into with fill. I want to tell you everything right now. So we have to add these things up, and we could do it the long version where we'd have to convert everything to 30 seconds. Everything would have to match, right? So we would have to do 1/16, 3/32, and 1/4, and we have to find what the common denominator is. Which one's the denominator? Upstairs or downstairs? That's the bottom. So we'd have to find a common denominator, and I guess that's maybe what they're kind of thinking of. And the common denominator here is 32. So you'd have to multiply each one of these things by whatever it takes to get 32. So that what, times 2? 2, 1/1, and this would be 32, 8. 8. So that would be 2 30-seconds plus 3 times, 3 30-seconds, and then 8 30-seconds. We add the 3 plus the 2 plus the 8, 8, 12, 30, so we what, 13 30-seconds? All right, if you want to do it longhand, but we don't have to, do we? So how would we do this one? Punch it in. What are you going to punch in? Right, everybody remember that ABC key? Some of you, it's only been 2 weeks. Some of you, it's been a couple months since we did that. So quite simply, to make sure that I got it right, it would be 1, ABC, I don't think it looks like that because, yeah, little b, ABC 16 plus 3 ABC 32 plus 1 ABC 4. And what do you get? 13 30-seconds. Well, how was that? 13 30-seconds. What if I wanted that, and I would want it in 30 seconds, by the way, if I was dealing with rivets, but what if I wanted that in 1/16 of an inch?
Divide 13 by 2.
Let's think of an easy way we could do that. Yeah, with your calculator, what would you do? That's really annoying. So exactly. Go like this. What would we do? Without getting all mathy on everything, what's some ideas? How could we convert 13 30-second to some other fraction? I've stumped you. How would we convert this to a decimal? I want that in a decimal now. Okay, there's two easy ways to do it. Would be, what did you say?
I divide 13
13 divided by 32. So 13 divided by 32. That's way number one. Absolutely fine with that. Might be the fastest way. What's the other way? Okay, second key. We have 13 30-seconds displayed. Hit the second key and then the FD key. And what do I get for a decimal?
0.40625.
13 AB 32. Let me see. Second fraction decimal equals. What'd you get?
0.40625.
0.40625 is what we get as a decimal. How do we convert a decimal to a fraction?
Multiply it by which denominator you want.
Multiply it by whatever denominator you wanted. So without getting too crazy, now that I have it into a decimal, I know that I can convert it to anything I wanted to simply by multiplying it by the denominator I wanted. So what if I wanted the denominator to be 4? I want something over 4. What is it? How many fourths is that?
1.625 fourths.
1.625 fourths. Well, is that a proper fraction of any sort?
No.
It's not, but we just did it. Right? If I wanted it in, what did I say, sixteenths, what would it be in sixteenths?
6.5.
6.5. We can go all the way back to the start, do it again. We could say, well, or we knew it was point, we can just 13 30-seconds, so 13, ABC 32, turn it into a decimal, 0.40625 times 16. What do you get? You already told me. 6.5 30-seconds, or 16ths. Did we do 16ths? Yeah, 16ths. 6.5 16ths. Everybody follow me with that? All right. So it's not necessarily a correct fraction, but you're going to get numbers like this, especially when you're working with sheet metal. We might end up with something like a 4.5 30-seconds. And that is a good thing to come up with if we're working in sheet metal and we're trying to determine rivets. And the reason why, I was going to say, when you get there, you find out why. The reason why is because rivets come in 30-seconds of an inch width. And so we want to know how many, I'm sorry, that wouldn't work out. Lengths. They come in lengths of 16th inch. I was going the wrong way with this. So there, that would be a good number. Let me back up. So rivets come in 30-second width, 16th lengths. And so if I needed a rivet that ended up with the 6.5 16ths rivet size, I would know they need one that's 6.5. That's the size that it would come in. So, or something between 6 and a 7. But you'll get there when you get to it. So it's not uncommon in aviation, especially when you're working sheet metal, to come up with this mixed fraction where it's like a decimal for the numerator and a fixed for the denominator. So it's okay. So everybody's good with that? All right. So then we get into tolerance of something. So if I said the tolerance of something, well, what is the tolerance? I think that's a test question. What is it? Tolerance and clearance. I think that is a test question. What is the difference between a tolerance and a clearance? In fact, I think it was an oral practical question I used to have to ask. Difference between a tolerance and a clearance.
Tolerance is the parameters you have to stay within, and a clearance is the difference between the two.
Yes. Let's see if we can break that down a little bit. The tolerance is, now did you say it?
The parameters that you have to stay within.
Okay, parameters you have to stay in when you are
What?
making it.
Making.
Making it, so to speak. Because the way you said it was 100% correct, but if somebody didn't know, it'd be like, that sounded very similar. So tolerance is something that it's usually seen in your manufacturing. Like this needs to be made 1 inch plus or minus a tenth, right? That's a pretty big tolerance. Where a clearance is literally how something fits inside of something else. So like a piston pin fitting inside of a connecting rod or a piston, it's like, well, what is the difference between the two? So in tolerance, we could have something is, well, it's supposed to be 7/8 plus or minus 1/5 of an inch. And then the question is, what is the minimum and what is the maximum? And so what would you do for that?
Add a 1 and 1/5 to that or subtract it.
Yes. So it's question 1 is 7/8 minus 1/5 equals the minimum. And what is that, by the way?
27/40.
How much?
27/40.
27/40.
Yeah.
Okay.
And then the other direction, if you're going up, it would be 1 3/40.
So 7/8 that we do plus 1/5 equals the max. And so what is the max?
1 3/40.
1 and what?
3/40.
1 3/40. All right. I don't really want to work in those kind of weird ass fractions. Oops, I said ass. I shouldn't say that. Sorry. So I would much rather have this as a decimal. Then I could use what kind of tool? Micrometer, dial caliper, something like that. So what's 27/40 as a decimal? What's that? 0.675. I like that. That I can work with. How about 1 3/40? 1.075. That make more sense to you? Because it does to me. So I'm not going to, a lot of these I'm not going to do repetitive. And I'm really depending on you to stop me if I've gone over something that you need me to back up for. And remember, if you don't remember it, probably somebody else does it, because you have to say to yourself, well, I'm not the dumbest person in the room. That guy is. So if I don't get it, then I know he doesn't. So make sure you stop and ask. All right. Okay, so here's one out of a book. As I said, example in a book. I don't know where I got this from. A hole is centered in a block that measures 5 7/16 by 3 5/8. Where is the center of the hole? Where is the center? All right, let me think. Sometimes I write this stuff down and I'm not sure what the heck they're asking. So let's just say a block, not to scale, is 3 5/8. I think this is what they mean. 3 5/8 by 5 7/16. 5 7/16 from there to there. Yep. Let's see. Where is the center of the hole? Well, how would we figure that out? First, I got to figure out where the center is here. Then I have to figure out the center here. So what do you suggest how do you suggest we do that? Divide each side by 2. Well, let's see what happens. So 3 5/8. So we're going to use our calculator again, the ABC button. So it's 3 ABC 5 ABC 8. Divided by 2 equals
1 13/16.
So divided by 2 equals 1 and 13/16. All right. Sounds good so far. How about the other side? So 5 ABC 7 ABC 16 divided by 2 equals
2 and 15/16.
2 and what?
15/16.
2 and 15/16, huh? Let me check that. Everybody else get that? Yeah, that's kind of not what I wrote down here. Yeah, I got a different answer. What'd you guys get? 23 30 seconds. That's what I got. So 2 and 23 30-seconds by so we're going to measure in 1 and 13/16, and then we're going to measure over 2 and 23 30-seconds. Everybody follow that? Joseph, you have an angry resting face.
Yeah.
A lot of times I always look at him and goes, he doesn't get it. No, he's actually done it like
I've been
8.
told by a home teacher, I'm like, you look angry with it. Like, yeah.
He does, and it's scary. I'm glad he's over there. If it starts to go down, you're going to jump in front of us, right? He comes at me. All right. Let's see. Therefore, the one edge. Yeah, okay. We got it fantastic there. All right. Let me see. Oh, we don't have to do this one. I'm going to tell you what it was. Improper fraction to a mixed number. That was pretty simple. So if we had 7/4, yeah, 7/4. All we have to do is change that to a mixed number or back to a proper fraction. So 7/4 is not proper, right? Because the numerator is higher than the denominator, so it's not proper. And we want that in a proper fraction because my ruler does not have 7/4 on it. So how would we change that into a proper fraction?
4 ABC 7 ABC 4.
There we go. So 4 ABC, oops, I already screwed it up. 4 ABC 7. Then what?
You get 1 and 3/4.
Well, you got to hit more than 4 ABC 7.
Oh, enter.
Enter equals, and I get, nope, I get 4/7 if I do that. So that didn't work out.
7 ABC 4.
Yeah.
Oh, I did screw it up. I'm so sorry. Let's see, 7 ABC 4 equals, oh, there we go, thank you. 1 3/4. Well, obviously you get it. I don't, so there we go. So, all right. Let's see. Yeah. Let's see. Converting fractions to decimals. Well, we already did that. Converting decimal to fraction. We can just make sure everybody's good for that one for a little bit. Let's see. What is 0.09375? And I want that in 64ths. How many 64ths is that?
6.
I hear 6 64ths. How did you get that number? Multiply that by 64. That is going to equal 6, and that is 6 64ths. All right, let's see. 0.078125. This is for our friends at home who aren't as smart as you guys, and I want that in 64ths. So we multiply this times
64.
64, and the answer is?
5.
So it's 5 64ths. All right. And I think we've got this one covered, 1.1875. I want that as a fraction. Just want it as a fraction. How would I put that into a fraction?
Second F to D.
So very good, 1.1875, and we're going to use the second fraction to decimal. And what does that equal?
1 3/16.
Second, let me see. Fraction decimal equals 1 3/16. What if I don't want it in that? I want it in an improper fraction now.
You could just multiply directly.
Well,
Add 16 to the
well, now we're getting complicated. I mean, you're correct, but there's got to be a way we, for the dummies in the class to figure it out.
Is there 8 plus an 8 ABC key again? Or no?
Yep. How about second ABC key again? Let's try that. Second. Second ABC.
DE
Yeah.
is improper fraction.
What's that?
DE is improper fraction.
Yeah. So the second ABC function. So second ABC equals, and what do you get?
19/16.
19/16. So now we can take any decimal and we can change it into a proper fraction or an improper fraction if we so desire. So that's that second ABC key. If you look up top that, it just says ABC to D over E. D over E. So again, it's just manipulating the fraction around inside the calculator.
So with that key, you can also go the reverse direction, right? So you can change if you end up getting an improper fraction, so now on your calculator you can switch that around.
You could, but I think the equals will automatically do it.
Okay.
But if it doesn't, absolutely, then it's going to swap it. It's just like FD, fraction decimal, because remember that key actually looks like this. It's fraction decimal, and it's got an arrow going both ways. So it's going to just change whatever you have. And this does the same thing up here. It's got an arrow, so you can change whatever you have. So if you want it into a fraction, if you have a fraction, want a decimal, you hit that second FD key. You want it improper, proper, swap it in your calculator. There's really absolutely no reason. I mean, once you figure out these keys, you should be getting the math section on the FA exam should be the easiest part of the exam. You're like, all right, let's just sail through this thing and get to the hard stuff. Well, and then when you're going to get to be like, okay, this is electricity. Let's just sail through this. Then we'll get to the hard stuff. All right, let's see here. Did that. Did that. Oh, yeah, I mean, there's just a lot of questions like this. Select the fraction which is equal to, which fraction is equal to 0.025. And so what fraction? And I didn't write down all the possible answers. I just have the answer because that's all I care about.
Second fraction decimal.
So what'd you get?
1/40th.
0. Wait, I have to do that. It's 0.025, 0.025, and then we hit the second FD equals 1/40, and that is one of the answers on there. So there you go. What's that? I think all of these are. Yeah, so you should recognize a couple of them. Same thing. 1.21875 is equal to what decimal?
Decimal.
Fraction. Yeah, well, it's 1.21875. It's a trick question.
1 7/32.
1 7/32. Everybody agree?
Yep.
Just playing along? Okay. You have a different calculator. You cool with that?
The only thing I'm missing is the ABC button, I think.
Zach, that one is everything, though. Because without that,
A little harder.
yeah, there's your fraction decimal.
I've been using that one. Yeah, I've got mine.
All right, let me see. All right, this is one that your calculator, wait a minute, I think it does. I just don't remember how to do it. I'm not sure. Percents. So 7/8 as a percent. How would you do that one?
7 divided by 8, and then the second percent key.
Okay, so you're going to convert to a decimal on your own. So either 7 divided by 8 or 7 ABC 8 equals, and you get,
87.5%.
so it's, no, that as a decimal is 0.875. Okay, so we're at 0.875, but I want it as a percent. So I just add a percent sign, right?
No,
Now, what do I got to do?
you gotta move the decimal sign 2 places to the right.
We got to move it.
Multiply by 100.
How do we remember which way it goes?
Because 1 is 100.
That's my guy, because 1 equals 100%, right? So if I can remember that much, and I can, thankfully,
I don't know about that.
then I remembered it. And once you said it, then I just know that, well, then I just got, that's 1 point equals 100%. So I just got to move the decimal place over 1, 2 times, so it goes to the right. So I just got to move this to the right. So I literally, there's nothing wrong with doing that. Just go, like I said, do this on a piece of scratch paper. Oh yeah, just make sure I'm going the right way. Because you'd be surprised how many people are going to turn in papers that are going to say 0.00875%. I'm like, nope. It is 2 places to the right, therefore it is 87.5%. I don't remember if there was a special function.
There is, you do 7 divided by 8 and then second percentage key, it'll automatically spit out.
Does it? Okay, let me try that. 7 divided by 8 equals, well, you just 875. Second, that's,
Could you just multiply by 100 in any case?
oh, I wouldn't do that. Oh, of course you could, if you remember that.
Were you saying you wouldn't do that to what I said or what to he said?
If I have 0.875 second percent equals, it goes 0.00875.
No,
I think
I
you
did
gotta-
7 divided by 8 and then hit the percentage key before I hit enter for 7 divided by 8.
Oh, you turn, okay. You made it 7-8%. That's a good point. So you could do that. If it asked you that, okay, so what he did is different. He just said, okay, if they want 7/8 as a percent, well, then I'll just put 7/8% into my calculator. Well, I like that. That works. I just put 7, okay, calculator at 7/8%, and now all I want to do is make it into a decimal.
Well, wait, but that gives you, you're saying put 7 ABC,
8.
and then
Percent.
percent. But that comes out to
That doesn't work.
0.00875.
Let me see.
That goes the other way.
7
Oh.
divided by 8.
Okay. He did 7 divided by 8%, which is kind of, I have another calculator that is a financial calculator. It would literally do 7 divided by 8%, but then it would give me an error because like 8% of what? So I don't know, this one happens to work. If you plug it in just like that, 7 divided by 8 second percent, it will do it. 7 divided by 8 second percent
It
equals.
doesn't even work if you bracket 7 divided by 8. It gets the wrong answer. It has to be.
He's saying it's 7 divided by 8 second percent. Percent.
Yeah, yeah. No, but if you put the 7 divided by 8 in parentheses,
Oh, yeah,
it
it
won't
doesn't.
work.
All right, so I don't know. I don't think I would.
By 100. Yeah.
You're back with me? I don't think it worked, but I don't know if I'd remember that one too well. They kind of be like, well, that confuses me. I think I would stick with this one here. I feel like this 7 divided by 8, turn it into a decimal, move it over the places to the right is the safer way to go for me. That's where I'm going to stick with it. You can do however you like. Do one more just to, so what is 5/8 as a percent? What percent is that? So I'm going to do 5 divided by 8. 5 divided by 8 equals 0.625, 0.625, and I'm going to move the decimal place over 2 places to the right, so I'm going to have 62.5%, and I'm going to leave it at that. All right. All right, so here's another question for you. Shifting gears a little bit. Let's see. A certain aircraft bolt has an overall length of 1.5 inches. 1 1/2 inches. With a shank length, the shank length is 1 3/16. 1 3/16, and a threaded portion of 5/8. 5/8. What is the grip length? Well, to figure that one out, there's a couple things you have to know a little bit. We did talk about this in 309. So the first question is, what the hell did you just draw, Kevin? All right, so I got a bolt. What's the overall length? Is it from here to here or here to here? Ah, it's this one. The head counts for nothing.
Bolt size.
Yeah. Good one. Get out. People can't hear the jokes, I forget it. He said bolt size, which is really funny. All right, so the overall length right here is then, scroll this way, 1.5. 1 1/2. And the shank then,
It's under.
wait a minute,
Yeah.
something ain't right here.
1.5 and yeah.
I think the overall length is what they gave us is actually this much. Because otherwise, what is the shank? And the threads, they want to know what the grip is. What is the grip? That is this. That is the grip. And so if they're saying overall length is 1.5, and we know that to measure a bolt, you must use this right here, and they're saying that the threads are right here, 5/8, then something's wrong. Or they're just giving me information I don't need. So I'm going to try it both ways. So if the overall length is 1.5, and the shank is no, it can't be. This is the shank is right there. So that means that this must be 1 3/16 according to their equation. And this must be 1 1/2. Let's try it. This is the thing you're going to deal with when you deal with the FA questions. You're going to be left going, wait a minute. What are you asking me? So what would I do? I would take 1 3/16, and I would subtract what?
5/8.
5/8. And I would see what that gave me.
9/16.
All right. So that equals 1 ABC 3 ABC 16 minus 5 ABC 8 equals 9/16. And what if 9/16 is the answer on the test? An answer, possible answer. I would say I'd go with that. That's the only thing that makes any sense. Everybody follow that? That was a tricky one because they gave you information that doesn't really match what we know. So what is it? It's the 1.5 is a misleading number right there. So when they say overall this time, they mean the overall, like the whole length of the bolt, which we don't use for measuring anything for bolts. If you remember, we only measure the shank. So the answer would then be 9/16, and that's the answer I wrote down. What is that as a decimal? Because maybe the answer's in decimal.
15625.
And you just did second FD.
Yes, sir.
Second FD equals. Hello.
Hi.
You here for somebody?
Is this introduction to electronics?
No. This would be AMTP 300.
300?
Yes.
Are you allowing people to add?
No. No. You have to have completed AMTP 309 first.
Okay, 309.
Yes.
This is 300?
This is 300.
Okay. Okay. Are they offering 309 this semester?
Not until the summer.
Is that the first class everybody's got to take?
Mhm.
Yeah.
Okay. All right, thanks.
Good luck.
They don't do it in the winter anymore?
No. No. And then you got to show up on time. Okay. Okay. Let's see. What do we else have here? Certain bolt. Okay, this test question says select the fractional equivalent for a 0.0625 inch thick sheet of aluminum. 0.0625 says select the fractional equivalent. What is the fractional equivalent? Well, it's just that. Fraction decimal equals 1/16. What would you do if you didn't have the FD key?
Probably
Figure it
stay
out.
home.
Multiply 0.0625 by 16.
Well, yeah, you'd look at the answers that you have and then just try each one until you got the one you wanted. So I liked your answer. Was it stay home?
Stay home and drink.
All right. Oh, answer choices. I wrote the answer choices were 3/64, 1/32, or 1/16. So, hey, guess what? We got the right one. Select the decimal, let me see, which is most nearly equal to 77/64. What decimal is most nearly equal to? And that would just be our second fraction decimal equals. What's the matter?
1.20315.
You guys okay?
Oh, no, we was,
Which question? Don't be shy.
Oh, I was just saying if you didn't have the FTP, just multiply each denominator.
Say it again.
I said if you didn't have the FTP, just multiply each denominator that you had.
Yes. Yeah, if you didn't have the FD key, I'd multiply 0.065 times 64. See what that answer is. Then I'd do that times 32. See what the answer is. So that's what I do. You only have 3 choices. Like, how hard could it be? All right, what was my answer here? 77/64 says most nearly equal to
1.20315.
1.20312.5. All right. All right, I like this one, I think. Let's see. A blueprint shows a hole. A hole. We need a hole that is 0.17187 to be drilled. What fraction drill size bit is most nearly equal? Your answer choices are 9/32, 11/32, and 11/64. What do you like? Let's do this. What is this one? If you do fraction decimal, what does this equal? What do you get?
Yes.
What's that?
Yeah, it's self.
Self. Okay, you get nothing. So that equals that. So it doesn't work. So now we're kind of stuck. So we'll do it this way. So 930. So I don't want to do that. Come on, erase. All right. So times 32 equals what? What did you get when you multiply it times 32? 5.49984. And when you multiplied it times, okay, so that takes care of 2 of them. Then you multiply it times 64. What'd you get? 10.99968. So, all right, so multiplied it by 32, so that's 5.5. That doesn't work for that one, right? So, nope. Doesn't work for that, so nope. So, 10.99999, that's pretty dang close to 11. So, 11/64. Which decimal is most nearly equal to a bend radius? Bend radius. Who do bend radiuses in sheet metal? You'll have fun with that. 31/64. Which decimal is most nearly equal to that bend radius? All right, so we'll just use the fraction decimal key. We will get 0.484375. And for some reason I wrote down here, we need to round to the nearest 10,000th. Round to the nearest 10,000ths. All right, so now we got to go back and think about that. So this place right here is the how much? Tenths. This one is the
hundredths.
This one is the
Thousands.
That one is the
10,000s.
All right, so it's going to round to the nearest that. So 484,375. We have to round to that one. So we look at the number over here, which is
Above 5.
5 or bigger. It is above 5. You are correct. But I'd say 5 or bigger. Therefore, that becomes 0.484. 4 is correct. The radius of a piece of round stock is 7/32. Select the decimal which is most nearly equal to the diameter.
0.21875.
Radius. The radius, it says the radius of a piece of round stock is that. Select the decimal which is most nearly equal to the diameter. They're going to get you on that one.
So that would be divided by 2.
So if we look at a drawing of it, the radius right there is 7/32. And they want to know what the diameter is.
7/16.
So that is just what times what? 7/32 times 2 equals 7/16. With a decimal equivalent of,
0.4375.
because I think the answer was actually in decimals, so 0.4375. All right. Feeling good about that? Nope. Of course you are. All right. Order of operation. Your calculator does have brackets. For some reason, I just choose not to. I don't know. I kind of like looking at things and how it flows. And so I don't use the brackets very much. But order of operation is, say it with me, please excuse my dear Aunt Sally. Well, I had a student one time who had a very nasty version of this. I don't remember what it was. I'm sorry. So, and I put so P is for what? Parentheses. Now I'd have to spell parentheses, P-A-R-E-N-T. These things. That is the first order, then that, then that, then that. So, then E is exponents, such as squares or square roots. M and D. Right, and the reason why I wrote it on that line and not straight down is because they have equivalents. They are not one over the other, but it goes left to right. So it's multiplication and division from left to right. And A and S is addition and subtraction from left to right. So, okay, so here is an equation that they have given us. Solve the equation. 4 times -3 plus 9 times 2 divided by 2. All right, so what's the first thing we're going to do? And that's not 4x, it is thankfully, otherwise it'd be like, oh my God. So we're going to work what is inside of the parentheses individually. So we have 4 times a -3. So 4 times a -3 is? -12. I'm going to keep that in the parentheses just to make it kind of easy for me. Plus 9 times 2? 18. I'll keep that in the parentheses. And now we can solve the outer brackets parentheses. -12 plus 18 is?
6.
Are we sure about that?
Yes.
Okay, so that is 6 divided by 2 equals 3. That would be true, except I wrote this down wrong. Let's try it again. 4 times -3. Numbers matter, huh? Plus -9 times 2. Good practice, good practice. All right, 4 times -3. -12 plus -18. What is -12 plus -18? -30. And if we didn't know that, everybody knows where the little negative key is down there on the bottom left-hand corner, right-hand corner. So -30 divided by 2 equals? -15 would be the correct answer this time. All right, solve the equation. Some of these are kind of easy. 64, where'd I go? 64 times 3/8 divided by 3/4 parentheses. So first thing we're going to do is, I should let you just do it. And what did you get? Well, if we did it correctly by the parentheses, don't believe it would matter. You're still going to get the same answer. We would get 64 times 3/8 would equal 24 divided by 3/4, and then 24 divided by 3/4 is 32. All right. Next one is pretty much the same thing. What the heck? You know what? I get paid by the hour. 32 times 3/8 divided by 1/6 equals 72, says the man in the back. 72. Anybody disagree? Anybody agree?
Yes.
Okay, 72. Not going too fast for anybody, I hope. All right, this one's a little bit different. This one's fun. Okay, so 1/2, I just have to write it down correctly. -30 plus 34, 5 equals. Okay, so this one, if you're not familiar, we're going to start in the same spot inside the parentheses. So -30 plus 34 is going to equal 4. Okay, so we have 4, 1/2, and 5. So that just means times when it's next to this right here. So that means times that times that. So it's 1/2 times 4 times 5. 1/2 times 4 times 5. That equals 10. 10. Not bad. Let me see. Well, this one's a little more complicated. Let me see. 4 minus 3 bracket -6. 2 plus 3 plus 4 close bracket equals. So what do we got here? What'd you get? 100. I don't even know.
136.
I got 312.
Let me see. 4 minus 3, -6,
Oh, I did it
2
wrong.
plus 3 plus. Yeah, I got something different here.
I got 82.
Let's see here. What's the first thing we should do? Not what you did. What's that?
The 2 plus 3.
2 plus 3. So 2 plus 3 is
5.
5. So we have -6 times 5 plus 4. Right? Is that what you get inside there?
Yes. -6.
Okay, this is 4 minus 3. So to solve for this, what are we going to do?
-6 times 5.
-6 times 5 is? -30 plus 4, that is? -26. So I have -26, 3, 4. So now what do we do? Well, it's 3. It's not -3. It's 3 times -26 is?
-78.
-78. Is that correct? Okay, -78. So 3 times -26 is -78. So I have 4 minus -78. And 4 minus a -78 equals 82. That's the tricky part right here, is realizing this is 4 minus 3, not -3 times 26. That's not correct. It's.
You still get the same result.
Would you? All right.
Because it would just subtract the.
Okay, but then you have to be careful, because then does that change that? So
Maybe if it was more complicated, it'd have.
It's just the way I was taught was to treat that as if it was, because the negative does still apply to the 3 anyways.
yeah, I do too, but I want to say I did something and it came out wrong. I'm like, oh, I should tell you not to on this one, but so okay, let's try that. So if we did -3 times -26, that is,
Just positive 20, 78.
that's 78. So we have, then we have what, 4 minus 78?
plus.
Plus.
So it would get rid of that it would get rid of that subtraction.
You already used the negative.
Yeah, so then you got to remember to,
But then
Do
it would,
that.
that would be 4 times 78.
Yeah.
which is true. Yeah, but then you have to remember to change it. See, to me that starts to become confusing. It's like, oh, no, if I remember just to leave the negative here and call this a positive 3, then I don't get into that confusing kind of a thing there. Like, what do we do with that and change it? So that's just the way I like to do it, I guess. So, but yes, point well taken. All right, break time.